6 terrifying ways the universe could end tomorrow. Somewhere in the vast emptiness of space lies a story you've never truly heard. And if you stay until the end, you might see Earth just a little differently. Share your thoughts below or your own theories from the void. Part 1. The illusion of safety. You feel safe right now. Feel the ground beneath your feet, solid and unmoving. You see the sun rise and set with comforting predictability. Our world feels like a sanctuary, a calm, stable island in a quiet cosmic ocean. But this feeling is the greatest illusion of all. The truth is, we are living on a fragile vessel, drifting through a universe that is profoundly dangerous. It is a place filled with forces so powerful they could extinguish our world in the blink of an eye. We are not safe. We have never been safe. We have only ever been lucky. So today we embark on a journey to confront the most terrifying ways the universe could destroy us. We will explore the silent hunters that stalk the darkness between the stars. And we will face the possibility that the very laws of physics are a ticking time bomb waiting to go off. This is the story of our beautiful and terrifying home. Our first stop on this journey is a cosmic monster, a creature of pure gravity so dense that nothing can escape its grasp. It's not even light itself. It is an object that Albert Einstein himself, in his own theories, struggled to believe could actually exist. But they are real, and they are wandering through our galaxy right now. They are the silent, invisible assassins of the cosmos. They're the rogue black holes. These are not the supermassive black holes you find at the center of galaxies. These are smaller, stellar mass black holes. They are the collapsed corpses of giant stars. When a star many times more massive than our sun runs out of fuel, it collapses under its own immense gravity. This collapse is so violent, so absolute, that it crushes matter down to an infinitely small point. And it creates a gravitational field so powerful, it becomes a tear in the fabric of space-time itself. Often, the supernova explosion that creates them is not perfectly symmetrical. It acts like a cosmic rocket engine, kicking the newborn black hole out of its home system, and sending it careening through the galaxy at immense speeds. A ghost, set loose to wander the darkness for eternity. A black hole with the same mass as our sun would have a diameter of only 6 kilometers. It emits no light, no heat, no radiation. It is a perfect sphere of blackness against the blackness of space, making them almost impossible to detect until it's far too late. And the most terrifying part? They are not rare. Our galaxy is old. It has seen billions of massive stars live and die. Astronomers estimate there could be as many as 500 million of these rogue black holes. Wandering the Milky Way right now? Part 2. The Wandering Death. So, what would happen if one of these silent hunters were to drift into our own solar system? The devastation would be absolute, and it could happen in 3 horrifying ways. The first and most obvious is direct impact. However, this is the least likely scenario. Space is vast, and a 6-kilometer object is a tiny target. The probability of a direct hit is incredibly low, perhaps 1 in 100,000 over the galaxy's lifespan. But if it were to happen, the Earth would not stand a chance. The black hole's gravity would tear through our planet like a bullet through paper. It would consume the entire world, piece by piece, swallowing our home whole, leaving not even dust behind. The second method of destruction is far more gruesome. It is a process known as spaghettification. Even if the black hole only passed near the Earth, its gravity would wreak havoc. The gravitational pull on the side of the Earth closer to the black hole would be immensely stronger than the pull on the far side. This difference in force, called a tidal force, would begin to stretch our planet. The Earth would elongate, distorting its shape. Then it would be pulled apart, breaking into a stream of fragments. This stream of rock and magma would be stretched thinner and thinner until it became a long, glowing noodle of atoms spiraling into the black hole's abyss. A horrifying end where our entire world is turned into cosmic spaghetti. But the third scenario is the most probable, and in some ways, the most terrifying. The black hole wouldn't even need to come close to Earth. It would only need to pass through the outer edges of our solar system. Its immense gravity would act like a wrecking ball, irrevocably scrambling the delicate gravitational balance that holds our planets in their orbits. Jupiter could be pushed closer to the Sun. Mars could be ejected from the system entirely, and Earth, a perfect circular orbit, could be twisted into a chaotic elliptical one. This would plunge us into extreme ice ages and unbearable heat waves. Or worse, our planet could be slingshotted by the black hole's gravity, either flung directly into the fiery surface of the Sun, or ejected completely from the solar system. Doomed to become a rogue planet ourselves, a frozen, lifeless ice ball, wandering the eternal darkness alone. This is the most likely scenario, and it carries a terrifying probability of about 1 in 10,000. A silent hunter could, at any moment, be drifting our way. Part 3. The cosmic cannons, but black holes are not the only threat lurking in the darkness. The universe is also home to explosions so powerful, they make a supernova look like a firecracker. They're called gamma ray bursts, or GRBs, and they are the most violent events in the universe since the Big Bang itself. A GRB is born from the death of a very specific, very massive type of star, or the collision of two ultra-dense neutron stars. When these events occur, they don't just explode outwards. They focus almost all of their immense energy into two narrow, powerful jets of radiation. Beams of pure destruction traveling across the cosmos at the speed of light. These are the universe's death rays. If one of these cosmic cannons were aimed directly at Earth, the consequences would be catastrophic. You would have no warning. The beam would be invisible until the moment it hit our atmosphere. In a matter of seconds, the intense gamma radiation would completely strip away our planet's protective ozone layer. Without the ozone layer, the full, unfiltered, deadly radiation from our own sun would pour down upon the surface. It would scorch the land and boil the surface of the oceans. It would cause a breakdown in the DNA of all living things. Life on the surface would be extinguished almost instantly. It would trigger a mass extinction event on a scale we have never seen. The sky itself would be changed, with chemical reactions in the atmosphere creating a thick, brown smog. The light of our sun would be dimmed for years. How likely is this? Luckily, a GRB from another galaxy is too far away to harm us. The threat must come from within our own Milky Way, and it must be aimed directly at us. The odds are low, but they are not zero. Astronomers have identified potential candidates, like the massive star WR104, whose rotational axis appears to be pointed uncomfortably close in our direction. Furthermore, some scientists believe that a mass extinction event on Earth 450 million years ago, the Ordovician-Silurian extinction, may have been caused by a GRB from a nearby star. The universe, it seems, has tried to kill us before. We're living in a cosmic shooting gallery, and we can only hope that we are not in the line of fire. Part 4. The false promise of stability. But what if the greatest threat is not an external object? It's like a black hole or a gamma ray burst. What if the threat is already here, woven into the very fabric of reality itself? This leads us to a concept far more terrifying than any cosmic monster. It is the idea of vacuum decay, an event that could not just destroy the Earth, but could erase the entire universe in the blink of an eye. To understand this, we must first understand the quantum fields that create our reality. Quantum field theory tells us that the universe is permeated by invisible fields. These fields determine how all particles interact. They are, in essence, the laws of physics. Like all things in nature, these fields seek their lowest possible energy state, a state of perfect stability, known as the true vacuum. Physicists believe that almost all the fields in our universe have already settled into their true vacuum state. All except for one, the most important one, the Higgs field. The Higgs field is what gives all other particles their mass. It is fundamental to our existence. But what if the Higgs field we live in is not truly stable? What if it is only metastable? Imagine a ball rolling down a hill, comes to rest in a small valley partway down. The ball is still, it seems stable, but is not at the bottom of the hill. There is a lower, more stable valley far below it. Our universe, our Higgs field, may be that ball in that small valley. It is in a false vacuum. It seems stable, but it's not. It still has the potential to fall to a lower true energy state. How could this happen? Through a random quantum fluctuation, a process called quantum tunneling, somewhere anywhere in the vastness of the universe. A tiny section of the Higgs field could randomly tunnel through the energy barrier and collapse into its true vacuum state. And if that happens, it would trigger the ultimate chain reaction. A bubble of this true vacuum would form, and it would begin to expand outwards in all directions at the speed of light. It would be a wave of absolute annihilation, a wave that rewrites the laws of physics as it passes. Anything it touched would be instantly erased from existence. The Earth would vanish, the Sun would vanish, our entire galaxy would vanish. We would never see it coming. There would be no warning. One moment our universe exists. The next, it is replaced by something new, something different, with new laws of physics we cannot possibly comprehend. Perhaps life would form again in this new universe, but it would be a universe built on the ashes of our own. The question is, are we living on borrowed time? Is our universe a stable home, or just a temporary valley, waiting for the inevitable fall? Part 5. The dying of the light. The threats we have discussed so far are matters of probability, cosmic accidents that could happen. But there is one threat that is not a possibility. It is a certainty. It is the inevitable death of our own star, the Sun. This is not a question of if, but when. Our Sun is a middle-aged star. It has been burning steadily for 4.6 billion years, but its fuel is finite. In about 5 billion years from now, it will run out of the hydrogen in its core, and then its final dramatic act will begin. Gravity will crush the core, causing it to heat up immensely. This new heat will cause the outer layers of the Sun to expand outwards, dramatically. The Sun will swell into a red giant. Its surface will grow so large that it will engulf the orbits of Mercury and Venus, and then it will reach for Earth. The process will be slow and terrifying. As the Sun expands, its intense heat will scorch our planet. The oceans will boil away completely. The atmosphere will be stripped away into space. The surface of the Earth will become a molten, cracked desert, a lifeless, charred rock. Eventually, the expanding Sun will swallow our world whole. The Earth will vaporize within the star that once gave it life. This is not a theory. It is our planet's destiny. It is the one apocalypse that is written in the laws of physics. There's no escaping it. After its red giant phase, the Sun will shed its outer layers, creating a beautiful planetary nebula. Its core will collapse into a white dwarf, a hot, dense, Earth-sized ember that will slowly cool over trillions of years until it becomes a cold, dead black dwarf. A final dark gravestone for our once vibrant solar system. This is the natural life cycle of stars, and it is the ultimate reminder of our own impermanence. We exist in a brief, beautiful, sunlit moment. A fleeting spring between a fiery birth and an icy death. Part 6. Conclusion. A home in the darkness, so we find ourselves in a dangerous universe. We are stalked by invisible black holes. We are targeted by cosmic death rays. The very fabric of our reality may be unstable, and our own star will one day become our destroyer. The feeling of safety is an illusion. Our existence is a statistical improbability, a fragile miracle. And this knowledge can be terrifying. It can make us feel small, insignificant, and powerless. But it can also do the opposite. It can fill us with a profound sense of wonder. The fact that we are here at all, that we exist on this beautiful blue marble, in this brief, sunlit moment of cosmic history is the greatest miracle of all. We are the universe made conscious. We are the part of the cosmos that can look up at the sky and appreciate its terrible, beautiful, and awesome majesty. Our home is a dangerous place, but it is the only home we have. And the knowledge of its fragility should not lead us to despair. It should lead us to cherish it, to protect it, and to explore its mysteries with courage and with awe. Because our brief moment in the Sun is a gift of incomprehensible value. The universe is a dark and dangerous place. But for now, for this one precious moment in eternity, it is ours. The more we learn, the stranger it all becomes. Until next time, keep wandering in the void.